So welcome
Thank you.
everyone. I'm Elsa Lundberg, a Global Channel Communications intern, and I want to welcome you to our DevTalk webinar. Today, our presenters are Shashi and Nikhil, who are both from our Advanced Location Technology Engineering team, and they will discuss how to get the absolute most out of your Zebra RFID handheld and mobile computers through strategic tuning and developer best practices. Now, I'll hand it over to our presenter, Shashi. The floor is yours.
Thank you, Lisa. Thank you all for joining today's session. My name is Shashi, and I'll be accompanied with Nikhil running through these slides. Right. So we will walk through over the next 40 minutes. I think we'll walk through how to get the most out of Zebra's RFID handheld and mobile computer portfolios, right? Including understanding on Gen 2X and how it can help you fine-tune performance for real-world use cases. Whether you're building inventory apps, the cycle count tools, or any sort of portal solutions. So this session is designed to give you the practical and developer focused guidance you know uh, on how to apply this immediately and to solve your the operations challenges. Okay, so now let's see. Uh, you know, uh, I want to kind of make you understand the powerful foundation the Zebra industry leading RFID devices already provide. Out of the box, right? Secondly, to look at the strategic tuning um, and extending not just the conventional configurations, to handle all your uh, use case operational challenges, how to extend, the Gen 2X configurations, which the Zebra devices provide, and help you to further fine tune your specific use cases, right? Thirdly, after going through this, let's understand, an actionable, developer focused strategic uh, to get the absolute most out of your hardware. What are the best practices as a developer in order to get these things? Okay? So, okay, let's run through. So what are the agendas that we will cover today? So, to begin with, let's understand the RFID handheld product portfolios. It's very important to understand this, like how we can apply configurations and tuning based on these things. And then let's understand what are the API, the SDK support that is being offered, excuse me, for all these handheld readers and the mobile computer readers. And let's also look into the out of the box support, right, that exists, for the easy integrations, right? Um, and then it's very important to understand the different reader profiles. Let's run through all the profiles that has been supported, and let's see how to adapt or use these profiles to yeah, to respective to your devices or the Zebra handheld readers to realize the use cases, right? So it's important to understand the profiles with respect to handheld readers and the mobile RFID readers. So let's cover that in the next agenda. And then finally, let's cover the extensions of the existing profiles or configurations, as Gen 2X configuration. So how to extend the available configurations with Gen 2X to achieve our operational challenges, right? Which is right. Okay, let's now understand this. hardware landscape here, the RFID handheld readers hardware landscape. See, there are two class of readers, as you can see. So we have this handheld reader devices, right? And then we have this mobile computer readers. And so these two classes is differentiated. If you really look at those configurations or the specifications, the handheld reader class devices are generally used, for a kind of a long read range use cases. They generally cover from 2 to 90 feet uh, read range, right? So it has a good maximum read rate. So we can go up to 1300 tags per second. And you can also configure, so we can reach this range, and then the power limits up to 36 dBm in some devices and up to 30 dBm in some devices, right? So then we have the other class of computer readers, or basically the mobile computer RFID readers, right? So they can be classified as with the based on the read range, right? Which they offer read range of 2 to 5 feet, and the maximum read rate that you can achieve there is 20 tags per second. And please note that it's these readers are always duty cycle. They perform always the duty cycle inventory. Call it smart inventory. Excuse me. And the power is limit for 24 dBm, and they offer limited link profiles support. Okay. Okay, so next let's understand, how we can integrate, or offer the integration options for these different class of devices. So as you see here, right, there are different subgroups, and each subgroups, we have the different API support for you to offer the, I mean, for the integration aspects. So if you see, we have the API, which is on .NET API support is there. We have the Android API support. We have the data bridge, and also the IoT connectors. So all these API supports, if you really look at, they are offered on Windows platform, the iOS platform, and we have it on the Android platform. Okay. Now let's understand, or let's check, out of the box how these readers are supported. Like, we don't have to start things from scratch. They already let's run through the tools and SDK support they offer. And if you really look at, they also provide the host connectivity or the terminal connectivity through Bluetooth and USB. So using this connectivity, we could start communication channels with these RFID readers. And we have a host set of the software tools support here, on iOS and Android. We have onto the RFID mobile, so where it can get tuned configurations, and out of the box can get started. We have onto the RFID desktop. Then and if you really look at, so we have SDK support to integrate and develop the applications or the use cases on uh, various platforms, like the iOS and Windows. And also, if you see, we also have the MOI SDK to offer the common development environment across platforms, right? So, similarly, we have this mobile readers. So mobile readers, they have uh, connected to the terminals. They are the built-in readers. So here we do have 1 to 3 RFID mobile support. Again, the standard Android RFID API 3, which is across a standard across the product portfolios, and the SDK with a similar API interface, and again the standard MOI SDK with a similar API interface. Then we also have the database support where user can straight away create the profiles and start and get this integrated into the web applications on or out of the box straight away it gets integrated. And then also the RFID CSP support for staging for various MDM frameworks, right? And if you really look at all the mobile readers, they are only on the Android platform. Okay, now let's go to the important aspects. It's very important for us to understand different RFID profiles that are available and which can be configured, either using the out of the box onto the RFID app tool sets and then immediately start using our reader. And it can also be, these profiles can also be created, right, and adapted to the various use cases to kind of handle the different operational challenges, right? So, so in both the case, we have both these two options. Let's and there is this. If you really look at it, so we offer all the tutorials and the code snippets are available, on the support central. So the link or the reference for it is given here on the right. Let's look into these. So what are those profiles that can be configured so that the maximum capability of the Zebra RFID readers can be obtained, right? So we have this fast read rate profile. Let's go into the details as we go through the next slides. So I'm just kind of categorizing the profiles here, listing those profiles here, which would be used in the corresponding use case scenarios. So we have this fast read rate. So we have the dense reader profile, the optimal battery, balanced performance, and then cycle count. So let's run through each of these profiles and look at the details. Yeah, so fast read rate. Um, so this so generally will basically configure our Zebra readers, right? Whenever we want to achieve maximum number of tags per second, and also at the best possible range. Right? So what are the use cases wherein I would go for this particular profile? Would whenever I want to achieve or want to get an high speed operations, right? Especially on the production lines, conveyor belts, and whenever I want to do the rapid inventory, right? Quick cycle counts and item, and then whenever I want to locate a particular item, so capability to keep reading that particular items repeatedly so that I can locate, right? So, so locate, when you combine with these pre-filters, right? You can read those tags repeatedly, or you can see those tags, specific tags repeatedly, and helps you to kind of get this, perform this locate and confirm use cases. So we need to understand, when we configure our reader for this particular use cases, right? So there are some benefits and there are some considerations that we'll have to keep in mind, right? So benefits, yeah, definitely we will get a peak data rate, right? Achieves the highest data rate, and since it's configured for maximum range, so you get the broad tag reading, capturing both the tags, all the tags, around. And then, the state unaware reads all tags regardless of their current state. So as we achieve this particular things, right? Um, so there are some considerations, as you build applications, like the power management, right? So you have to proactively understand the battery optimizations, during these when we configure for fast read rate. And so as we are covering the range and also the data rate, right? So there will be very high volume of redundant tag reads that are coming up to the applications. So application has to be robust to kind of handle, these high data streams, right? And also, there are some environmental factors that we'll have to keep in mind when we are doing the fast read rate, right? So the noisy areas, right, might come into the factor here for the accuracy, okay? And also the deployment density requires a careful setup planning, to avoid multi-reader interferences. So these are some of the considerations that we need to keep in mind as we develop the use case or the applications, right, for a fast read rate profile. Now let's see how we exactly achieve fast read rate, right? So if you really see the, 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 the recommended configurations to achieve this, so it has to be on session 0, right? And then we need to basically configure a high data rate link profile. Right? So based on the SKU of the devices you have, it has to be either FM0640K or M2320K. And the DPOs would be disabled so that we there is no duty cycling as we do the read rates because we want to do a fast read rate. And then we have to make sure all the tags which is there in the range participate repeatedly, right? So that's why we need to go in for AB flip and SL all. So it has to be a state unaware configurations. And since we want to cover the range, we set it to the highest power level, 30 dBm, uh, generally, the readers. Okay? So next, let's look at the dense reader mode. So dense reader mode, generally optimizes the read performance and reduces the redundant reads, in environment where multiple RFID readers operate simultaneously. So that's the primary goal. Now, so when you have multiple readers operating, right? So this would be an ideal profile because we want to reduce the interferences here. So what are the use cases, right? Let's look at some of the use cases where we might have this kind of a environment or a setup, right? Um, Multi-reader and managing inventory in spaces with overlapping reader coverages, inventorying areas with high concentration of tags, right? And especially the portals and transition points where you have multiple readers tracking those the item transitions, right? So as they move through doorways and choke points where we want to kind of uh, uh, keep reading, the tags needs to be read by multiple readers to keep track of uh, the items, right? So um, so what are the benefits, right, with this dense reader mode, right? So after tag is inventoried, yeah, it's important that we reduce the redundancy. Now, how do we reduce the redundancy? The configurations aims at using the S1 session and the S1 the persistence time. Right? So since the S1 persistence time, right? It reports it again, so it's kind of it has a limited persistence time. So at the same time, we need to balance out so that within that particular limited persistence time that S1 session offers, we need to have a good data rate a, a proper data rate is selected, right? So significantly, so with a good data stream, reduced redundant reads, So we will be able to, so with that benefits, we will achieve this dense reader mode. But the flip side, there are some considerations that you have to do, right? As I said. So this is optimized for targeted and specialized scanning, right? Generally, the bulk inventory tasks, right? Um, as I said, since the S1 offers the limited persistence time or the shorter persistence time, it's important to couple that with the good read rate settings to meet with S1 persistence timeout, right? So these are the considerations we need to take. So combining all these things, um, so we can achieve to recommended configurations for our dense reader mode. So it's going to be on session S1 with a good M 256K read rate and DPO disabled, and then the targeting the state A and making it state unaware configurations, right? And maintaining the full range by configuring it 30, with 30 dBm. Okay. Um, so next, let's cover the optimal battery mode. So we saw like how we could maximize the Zebra RFID readers for read rate for the fast read rate, and then how the capability of our RFID reader read rate with respect to dense reader configurations, right? So there are some considerations we had to take. So if we have to balance out those flip side there and then optimize that for a use case where we need maintaining the same capability, but we want to add the battery usage so that it can last for the shift duration. So probably then we should we'll see how we can achieve the optimal battery mode, maintaining the earlier characteristics, right? So again, here uh, for this primary goal, we need to enable the duty cycling so that we maintain the good read rate and we will reduce the redundant reads, right? So the benefits, as I said, significantly longer battery life, right? And also because we have the reduced redundant reads, we leverage the S1 session persistence to prevent redundant reading, offering the lower data input or the to the applications, maintaining the battery life. But still, there are some considerations here as we do it. So the read range expectations, right? So the lower output, uh, we have to kind of it's kind of the flip side is that it is since we're going to reduce the range, it's going to be more localized and targeted read area, right? Very best suited for inventory use cases where you want to do a single reader bulk counting and you want to use that for the entire shift without uh, you know uh, running for the charging or the battery swaps, right? So so we covered the use cases. Let's see how we achieve this optimal battery mode, right? So the recommended configurations in order to achieve this particular use cases. So we work on session S1, right? Link profiles is would be M4 256 with a good read rate. We will enable the DPO so that there is some battery saving. Query params will work again. We will open up for state A and all SL all target state A and state unaware configurations. Power level will reduce it to is will reduce to 24 dBm. So this is a good configuration set to achieve. battery life coupled with uh, uh, good read coverage so that we can execute use cases like uh, the single reader bulk counting use cases in the dense environments. Okay. And then let's see that if we want to how we can achieve balanced performance. So this is on one end, as we cover that initially, we covered that fast read rate and the dense reader mode, right? So where we had good range, good read rate, and then we kind of covered how we can optimize our Zebra RFID readers for battery life. Now, what if there is a use case, where I want to do the general inventory, on a multi-reader environment. I want to have a full shift operations, and at the same time, I want the reader configurations wherein I want to achieve use cases like the portal solutions, where I want to use that for my portal solutions development and the transition points, right? So in these cases, we need to have the balanced performance, right? So we can create a balanced performance profile as well. And the primary goal, as I said, we want to have, a good ratio or the good blending of, read rate, read range, and the battery efficiency, right? So the benefits we get with this is, again, as I said, good battery life, achieves, and then the reduced redundant reads, right? So we get good reduce redundant reads, leverage the S1 sessions, achieve the good tag reads, coverage of read rates, range of the read tag reads, and also have a balanced battery life, right? And achieve the use cases that which we covered. Now let's see the details on how we achieve this particular configurations on the Zebra readers, right? So we should be working on session S1 uh, and then configuring the link profiles with for M4 256. So DP enabled and working the with state A, session state A and state unaware configurations. And so the a balanced range power level to achieve the balance range. So we'll set the power level to 27 dpm, right? Okay, so now, so this is a very specific use case, right? The cycle count, um, where we want to do, there are a lot of scenarios where we want to do, the priority would be to do the bulk cycle counting. So that would be the primary and the most effective applications we might have, and we might want to do this in a high density environment, right? And we need also the good efficiency when we are doing this on a high density environment, covering a large number of tags, right? And we might also have a multi-reader setups, right? Where we want to do the cycle counting, right? So when we want to cover this use cases, we would be looking for a cycle count configurations or the cycle count profiles, right? So whenever we want to achieve this, we want to have increase the persistence. So that's why we would go for session S2, right? And this mode, as I said, is will be focused more on a good read rate. So we need to achieve good read rate. We need to achieve good range and also uh, thoroughly count a large tag populations, right? So when we want to do these things, I think we need to have a cycle count profiles, right? So before getting into the details, I think we also have to consider some of the considerations that we should know that is it's unsuitable for rapid recycles, right? Um, so because it's the extended we will be using the extended persistence of S2, right? So this mode is not recommended for applications requiring rapid back-to-back inventory checks, of the same area, right? So let's see the details of the configurations. So we would be using S2, link profile M4 256K, DPO disabled, state A and SL all, and since we want to cover the coverage, so it will be the 30 dBm power level, right? Okay. So now, briefly, I will say run through. So we ran through all the profiles that we would get the maximum capability for the corresponding use cases in our handheld readers. But please note that the same would not, we can't blindly apply the same for our mobile RFID readers profiles, right? So because of the hardware uh, 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 specification of mobile RFID readers. So the readers are always optimized for smart inventory. That is the duty cycles are mandated. And also some of the configurations are also limited with respect to TX power range, considering the regulatory, uh, the SAR and other aspects which we need to consider for the mobile RFID readers, right? So if you look at the way we achieve optimal battery balanced performance cycle count, it's not direct mapping of those things on the mobile readers. So there are the recommendations for optimal battery for the mobile RFID readers with respect to optimal battery would be to have the duty cycle on 15%, and the default TX power will be at 20 dBm. So these are the default profiles available on the mobile RFID readers, which users can apply using 123 RFID app, as I covered earlier, or using the SDK APIs. So it will be session S0 and tag population configured for 3 and link profile is 0 and inventory type will be AB flip. Similarly, the balanced performance, again, the duty cycle will be increased to 25% here to get the balanced performance, and working on the similar session and the tag populations or the query configurations, or the inventory configurations. Cycle count, uh, consider that, please note that, we'll be doing the smart periodic inventory at 30% duties cycles. As we covered, we will earlier, so it will be again session S2 with at 24 dBm. Right? And similarly, we have this max range, then with 24 dBm at 30% duty cycle, and the fastest read at 35% duty cycle. And the users can also create their own RFID profiles, right? And so where they can configure the duty cycle with respect to the min and max, and default the TX power can also be configured. Session again customizable, so you can customize and create your own RFID profiles, right? So before going after going to, after this, so we'll have a quick poll immediately, and then we will see the cover the extended configurations that Zebra RFID readers would provide. All right. Now get it the let's have the introduction to Gen 2X. Now, what is this Gen 2X? So Gen 2X is so we kind of had the foundation earlier, right? So how Gen 2 V2 session persistence characteristics were configured, right? And tuned to achieve various use cases, right? So, we had this rapid read on S0 we created the configurations for unique tags on for S1 and long-running multi-zone use cases in S2 and S3. Now the Gen 2X kind of offers the extended configurations, right? So or to support the specific use case operational challenges, right? On top of the Gen 2 V2 foundations, right? So let's see, how we do that and how it is done. So important is we cover the tag focus, right? So which is an extension on S1, the fast ID, how we can achieve the unique tag on any sessions, and then the tag whiting, how we can achieve ignoring the tags and then only kind of enable reading only the interested tags or the interested items, right? So please note, so this is all these extensions, how this configuration extensions are provided on the, let's run through like each one of them and how they are provided in our Zebra RFID readers, right? So tag focus so is used to enhance filtering in the dense environment, right? So the extremely uh, with dense environment, with hundreds thousands of simultaneous tag responses, right? Um, so see for standard or the lower volume environments, the standard session-based reading is usually sufficient. Please make a note that if you can achieve using the earlier configurations for your use case, I think you should continue with that. But only when you have your operational challenges to achieve the unique tag ratings, that's when, the Zebra offers the tag focus configurations, right? Let's see how this tag focus is kind of supported in our Zebra RFID readers, right? So we will, if you, so it's kind of as simple as calling this set tag focus, right, on an associated antenna ID, right? So once you enable the tag focus, apply the singulation settings, configure the reader control to perform the inventory operation specifically on tags. Please note this is within the session S1, right? So then you configure the session for S1, the state to A and SL all, right? So this would achieve the unique or the removes the duplicate tag reads and uh, uh, with this particular configurations. Let me go to the now we have a demo and so Nikhil, can you
Yeah.
take over
Thank you, Shashi.
and show this
Thank you, Shashi.
tag focus demo? Yeah.
Yeah. So in this demo, we showcase the implementation of this feature using our sample application. So what we'll do is we'll do an inventory here in this, and we'll compare it before and after enabling the tag focus feature, how the inventory performs. Yeah, you can play the video. Right. So I have. Now, as you can see, like I'm doing an inventory without enabling the tag focus. It You can see that there were multiple reads for the same tags there. So, but after enabling the tag focus, since it leverages on the session S1 persistence, uh, the tags that have been inventoried once are not reported again. So this allows reader to focus on discovering the remaining unread tags. So this is how the tag focus reduces repeated tag responses during the inventory. Yeah, next. Good, good. You
All right.
can go.
So tag whiting. Let's see now how the tag whiting works. So though again here the goal of this tag whiting is it's a way to temporarily silence specific tag populations, and then only read the interested tags or the tags of interest, right? So generally whenever the ideal use cases is like we want to remove the items or remove those tag populations which has already participated and in our defined space, right? And then focus on the tags which are not read so that you can perform actions. And as you perform action on those tags of interest, you want to remove it from the uh, reading from the reading zone, right? And also detecting when a tagged asset enters or leaves a specific area, right? So the mechanism is how the tag querying works is you read the tags, you perform the actions, and transition those particular tags to a specific state, right? And then using the tag query in a general fashion, you can say all those tags which has already been performed and which is there in this particular sessions, right? You can perform a specific actions. So you can give the state mask in general. You can give all the tags which are there in the specific states. You can define an actions. So that action could be like silencing those tags so that the other tags can participate, and that's how we can achieve um, you know, silencing out the tags which has already gone through the actions and the read the tags which is of interest, right? So how do we do this using the Zebra RFID SDK? Define
Shashi,
the target. Sorry. So how do we achieve tag quieting? Define the target session as I kind of mentioned earlier. So in general, we can select all those tags which are there in this known states, and then define the target and action against it. So this action could be to silence the tag or the known actions you want to perform, and then just apply the configurations, right? So we have a demo. So I'll ask Nikhil to run through the stack quieting demo.
Yeah. So in this demo, what we are doing is we have done a sample implementation of tag quieting feature where this is one possible workflow where we quite the selected tags and restore them using the unquiet operation. Yeah, you can play the video. So we do a normal inventory of tags here, and we select the tags which we want to quiet here, and we do the operation. Now, as you can see, the selected tags are silenced and the tags that are not quieted participate in the inventory here. We also have a select all option where you can quiet all the tags in batches of 31. Every 2 seconds, it quiets them. Yeah. So final operation is we restore the quieted tags using the unquiet operation that we have here. So this allows previously quieted tags to participate in the inventory session again. So the demo that we have is one specific workflow, but developers can use our APIs to design their workflow, which best fits their application requirements. Next slide.
Okay, now the fast ID. So fast ID is mainly uh, uh, used to get the unique tags, right? So it might so happen that the EPC of the tags might not be the global unique things that are available. So in order to achieve the uniqueness and to make sure we get the unique tags, so we can apply fast ID where the tags gets reported as a combination of EPC and the TID. Right, so that conventionally you might have to do two operation cycles in order to get this and then achieve the uniqueness, but extending the Zebra Fast ID configurations with one operational cycles, you can get the combination of TID and EPC to achieve the uniqueness in tag uniqueness in your use case or in the applications, right? So how it is implemented in our Zebra RFID SDK? So it's as simple as like enable with a single Boolean command, set fast ID and associate to the corresponding antenna ID, and so you would uh, get the unique tags. So again, so there is a demo, the fast ID demo.
Right. So in this demo, what we do is we will enable the fast ID and see how it changes the normal inventory responses when we enable the fast ID. Yeah. There. Yeah. So first we perform a normal inventory where standard EPC gets standard EPC is returned. Now we enable the fast ID. As you can see, the Gen2X tags returns both EPC and TID together in a single inventory response, while non-Gen2X tags continue to report only the EPC. By combining both values into a single operation, fast ID eliminates the need for additional TID read when we do an inventory operation. Next.
Okay. So we have this Gen2X radio performance configurations supported. So there might be some challenges, in the conventional using the conventional configurations, in the respect to the in the dense environment, or so there could be some environmental factors associating, for your read performances, right? So in those cases, I think you can extend the Gen2X radio performance configurations. So with this, I think you achieve the better radio performances. Um, you know, uh, cases where the environment could be playing a factor, or it could be a very high dense environment, and not able to conventionally achieve the read performances. But please note that, for this configurations, you have dependencies on the tags, right? So certainly the tags that are supported for this particular configurations are M830/850 tags, the version 2 of these tags, right? So since they have a dependencies, so if you there could be multiple environments with this tags only, and hybrid environment. So in all those, considering all these cases, you can configure accordingly, Gen 2, Gen 2X, or the hybrid mode, right? Okay. So you can check the, please make sure that, you use I think it's important that to summarize, we use the right profile for the device class and for the use case, and leverage the Gen2X feature strategically when the standard configurations aren't enough, right? So there are a lot of reference materials here, so can go through those things. So having said that, thanks, and probably now we can get into this question Q&A session.
Okay, thank you, Sashi. We do have quite a few questions in the chat for you. First question. So, from Kadar, what is the approximate read rate per second in different modes of terminal?
Yeah, so the read rate, again, when you say different modes, I think we are talking about the different configurations or the different profiles mode that we had covered. So
Mhm.
they would basically, I don't have that numbers. Probably we can kind of cover the exact read rate that we would achieve. But that read rate numbers that, again, there are so many other factors which would come into the pictures, right? The reader power that we have done, the antenna setup that we have, the tag density, and the environment, right? Considering all those things, so the read rate might fluctuate, but in ideal cases, we can achieve, as I said, in faster read rate, we can achieve 1000 up to 1000 to 1200 tags per second. Otherwise, and also the skew, the reader skew that we are using, right? Generally, we would achieve around 200 300 tags per second. Again, it depends. So those numbers corresponding to each of those profile mode on our ideal conditions, probably I can share or make that available on the tech docs.
Thank you, Sashi. Another one from Francois. Are all these mode or do all these modes apply irrespective of Gen 2X or no? Or is Gen 2X implicit in all of these modes? Does Gen 2X change anything insofar as battery duration?
All right. So these Gen 2, as I said earlier, as I covered earlier, Gen 2X is an extended configuration. So Gen 2X is not implicitly available. So the modes what we covered initially are the conventional or the standard, configurations using the conventional configurations offered by Gen 2 V2. Gen 2X is an extended configurations in for those use cases where you have some use case operational challenges to achieve with the conventional ones. That's when the Gen 2X is kind of extended. It's you can extend the configuration to use Gen 2X. And how does that influence the battery usage? I would say it's the Gen 2X provides the kind of a balanced performance. It gives you a good balanced performances. Again, as I said, Gen 2X is coupled with the conventional configurations, right? So, like some of the conventional configurations you provide along with the Gen 2X, like the power range and things like that. So that also adds contributes for your battery lifetime. So you can take the so again you can refer the modes that we had covered and extend that characteristics along with the Gen 2X to kind of solve your specific use case uh, challenges that you might have.
Thank you, Sashi. Another one from Mohan. How long do the tags remain quiet after the tag quieting operation?
Okay, this again it depends on sometimes it is also dependent on the tags.
Mhm.
So with using the Zebra RFID, we quiet the tags on S3 sessions, right? So we leverage the S2 and S3 persistence time uh, uh, to quiet the tag durations, right? So you basically you generalize all the tags, say which are there on S2 or S3 states, and then basically put it into a state where it is a kind of put it into a state change the state so that it remains quiet. So Indirectly or invariably, it depends on the S3's persistence time. So during those durations, you can keep achieving the tag-wide operations. So this is using the Zebra SDKs.
Thank you, Sashi. There are just two more. So Francois said he heard that the TID and partial EPC is in a single read as a hardware select filter. Would that be possible in Gen 3? And is there a partial implementation? Is it possible to do a hardware select filter on TID partial EPC, like CIN?
Currently, uh, no, okay, as I understand, so he wants the partial EPC selections using the pre-filter and then the along compile that with the TID. No, with if you have a Gen 2X, tag fast ID configurations, I don't think we'll be able to achieve that. No, for that, I think you need to go to the conventional way of doing it. The Gen 2X won't be able to offer that.
Okay, that is the last question. Um, do you want to go ahead and close this out, Sashi?
Sorry, is this is in the
As in, like, or I can go ahead and take this. All right.
mm,
Thank you for attending. Thank you, Sashi and Nikhil, for your support and giving this presentation. Um, the slides are available in the chat now, and they will be available on or via email. We send those out, and they are available on zebra.com in the Sports Center. Um, thank you for attending.
thank you all.